Good day, we're from PhilSCA Lipa campus, and this is our study entitled 3D gas turbine engine turbofan prototype. But first, let's have a short discussion of our study. 3D printed gas turbine engine plays a big role in terms of helping students, instructors, and the school by having a factual presentation that aids to give them a primary information regarding the gas turbine engine parts, expecting that this 3D printing will be introduced and adopted into education. By having this will be able to improve the overall learning experience for both students and teachers. And also, students are expected to easily recognize a gas turbine engine rather than reading it from textbooks or watching videos in order to gather information needed. Next, 3D printing gives both students and the teachers the power by making the learning process more dynamic. And aside from that, it not only helps the students to prepare for the near future, but also teaches them the usefulness of creating things using a definite approach. For education holds the key on unlocking the true potential of human ingenuity. Education should be more or multidimensional by integrating this 3D printing in education, which exposes the eager learners or the students and the future creators to stay adept with tomorrow's cutting-edge technology. 3D printing technology involves a user computer-aided design, or usually referred to as CAD software, to develop a model or obtain a 3D print file from a database or other sources, and using a 3D printer to produce a physical object. And once the 3D models or objects were made, it allows creative thought, improving the skills for developing new tools or models, stimulates special imagination, and this can be a collaborative activity that builds teamwork, and discover the strengths and weaknesses of the projects that transfer their ideas into reality, a 3D model. In short, we can see how this 3D model's potential could maximize the education experience of the creator, the students, and the instructors as the alternative or additional instructional tool. Next, we have here a statement of the problem. The purpose of our research is to assess the 3D turbofan prototype as perceived by the instructor and the students. Number 1, how do the instructors and students perceive the usefulness of the new 3D gas turbine engine for learning purposes in terms of information quality and efficiency of work? Second, what is the perceived advantages on the use of 3D gas turbine engine as a learning tool in terms of scale, durability, and its availability? Third, is there a significant difference between the response of students and instructors in regards with the perceived usefulness of the new 3D printed gas turbine engine for learning purposes? Lastly, based on the result, the researcher will demonstrate the perceived usefulness of the 3D gas turbine engine. And we have here the literature. According to Adrian Brandwood, head of design technology of Broughton High School, find its potential for experiential learning an incredibly powerful teaching tool. 3D printing has allowed an additional precision technique for all our students and innovate and experiment with. For Kevin Samuel, it gives both students and the teachers to go beyond the somewhat one-dimensional nature of textbooks, making the learning process more dynamic for everyone involved. For research gap, we have here the reason why we come up with this study. The 3D printing is one of many ways of acquiring tools and equipments in the forms of replicas and models, and inexpensive rapid prototyping, which creates personalized or desired items and manufactures with minimum waste. The researchers perceive that the 3D printed tools are useful, reliable, and have widespread availability, as well as the further development that will be more useful in the future, especially as an instructional tool for technical school like in aviation, and this will also help the schools in terms of their expenses. And we have here the conceptual frameworks. Input, we have the material used, the polylactic acid. It was recommended by our we collaborated with the engineers of 3D lab printing, and they recommend us to use the PLA for its cost and its strength. They have the printer, and they give us a design for the turbofan, and we have here the screws, aluminum pipes, and the bearings for assembly purposes. For the process, they gave us an estimation of 120 hours for the printing of the product, and we have here a demonstration examining of the material used, and lastly assessing the product produced. And for the output, the researchers respondents will be able to assess the perceived usefulness of the 3D gas turbine engine as an instructional tool and come up with conclusion and recommendation. And we are in experimental setup. As I've said earlier, the researchers collaborated with a 3D printing team in Batangas for the design and the printing of the 3D gas turbine engine. We brainstormed the product information and the concept of the product. The design of the product is based on an Airbus turbine engine and has a size of 10 by 10 inches, and the color of the product is based on the availability provided by the team. And the researchers come together to the estimation of 20,000 pesos of the product amount where it is being assembled on January 22, 2022. That is when all parts were made. The researchers also marked the timeline of the manufacture of the 3D gas turbine engine from October 2021 to January 2022. For designing and process, in this procedure, the researchers and the team decided with the printing of the design, make sure that every part will be proportioned and has a well structure if the product was already printed. In this part, the researchers will be needing to wait for printing process to be done. Assembling of the gas turbine on the 3rd, we've used the filament were used and ready for assembling the product, and there is a manual provided by the team to make sure that all parts and materials will be correct parts and minimize the errors in assembling the 3D gas turbine. Lastly, this is the 3D gas turbine product output, and as you can see here, we can distinguish the inlet fan, the compressors, low and high, combustion chambers, turbine section, the high and low, and lastly the exhaust. Next, the researchers provide the survey questionnaires for all A&D instructors and students, and as we gather and analyze the survey and put it on a test, the success results were seen, and here are the findings we gathered, conclusion and recommendation. Based on the statement of the problem, first, as the findings as perceived by the instructors and students among the information quality, the model components were clear and distinct with appropriate labels of information of a turbine engine, and we conclude that the 3D printed gas turbine engine model provides a clear understanding and enhances the education of both instructors and students. And we recommend to produce a bigger size rather than 10 by 10 in order to visualize the model in any distance in a classroom face-to-face setup, and add more tools such as hand tools and other equipment tools that can be made using a 3D printer. So second, as perceived by the instructors and students among the efficiency of work, 3D printed gas turbine engine will help the instructors and the students to lessen their workloads in combination with the textbooks as the primary source. In conclusion, this 3-dimensional printed engine will help both the instructors and students to lessen their workloads. And we recommend to use this 3D gas turbine engine as their instructional tool to enhance the quality of teaching in addition to the textbook. As perceived by instructors and students in terms of durability, replacing the actual turbine engine, the real turbine engine and the components used on the product is a good quality and perceived to have a long time use as an instructional tool. We conclude that 3D gas turbine engine is a good educational tool and is considered to have a good quality material for long-term use. And we recommend to use other printer filaments that can be tested to produce a sturdier complex models. And lastly, we have, as assessed by the instructors and students, there was a significant difference in the responses on the perceived of usefulness of the 3D printed gas turbine engine for learning purposes. We conclude that there is a significant difference in the responses on the perceived usefulness of the 3D printed gas turbine engine for learning purposes, and we recommend can serve as a basis in conducting related researchers in the same manner. The results presented in the study may be used to support and give substance to future studies. For this is the link for 3D gas turbine video, and these are the references that we've used, and that's all for our research. Thank you so much.